So let's talk now about how we represent this stuff. So we can talk about different ways of symbolically representing different types of atoms. So I consider these ways of telling you what I have because I need to know what I have. I need to know what isotope I have. I need to know what type of ion I have. I can use all of that information to give good feedback. So when we look at a periodic table, so we see these symbols here, we have the whole number in the corner. That'll tell me the atomic number or how many protons I have. So that whole number is the amount of protons. Then there's the mass, which that's the average of common isotopes. So when we take a sample of something, we're going to look at what type of isotopes I have in that region. Then we have the big symbol. This is the one that we usually represent it in class with. And then we have the name. So what is it? So isotopes are written in this way. So we'll commonly call it like hydrogen 3, and it's telling you the mass. So it's the protons plus neutrons. So hydrogen has 1 proton. So if the total mass is 3, then it must have 2 neutrons contributing to there. Carbon 14, carbon has 6 protons. So therefore, with carbon 14, there must be 8 neutrons. Protons plus neutrons is what's going to equal your mass. And there's other common ones that you may see, cobalt 60 and iodine. If you want to find out how many neutrons are there, look up cobalt, subtract the atomic number, the amount of protons, and then you can find out how many neutrons are there. Okay. Now these are what's called a full chemical symbol, and you'll see these quite often in class. So what we do is we write the symbol first, and then we could put the mass up here in the top left corner. We have the atomic number, or the amount of protons, that's going to be in the bottom left corner. And then the charge is in the top right corner. So we've already done the charge. We've been using that for a while. So you've seen these written in the top right corner of these element symbols for a while. The things that we're adding, however, is the mass and the protons. And what's really nice is it sets you up already for subtraction. So if I'm doing this one right here, we have the charge, so we know how many things are here. So we're going to look at what this is telling us. So we have 8 for my atomic number. That's my protons and atomic number. So protons right here are 8. Now look at this. Mass minus the protons is going to equal my neutrons here, which is also 8. Now, remember, this -2 means there are 2 more electrons here. So I have to add it to the protons, and I should get 10. Now, we look at the mass. Mass is 8 plus 8 equals 16. It's also up here in the corner. And now let's look over here for this one as well. So I can look over for protons. I know 16, that's my atomic number. I got my mass, which is 36. It's already written right there for me. 36 minus 16 is going to give me my neutrons. So that ends up being 20. And electrons, there are 2 more electrons here than protons. So I'm going to add it to here. So that's 18. Okay. And then over here, let's do the one for magnesium. So let's look at protons, neutrons, electrons, and mass. So protons, I have 12. That mass, I have 24. 24 minus 12 is 12 for neutrons. And then over here for charge, it commonly gets a +2 charge, which means there are 2 more protons, or there are 2 less electrons. So 12 minus 2, I'll have 10 electrons. And that's how we read these symbols. That's how we use them. It gives us a lot of information so that we can figure out what we're working with. So we're going to use these in class. We're going to fill out charts involving these. So we will need to know them. And again, if you need any help or any information, don't hesitate to ask. Talk to you soon. Bye.